Hi there, welcome back here, guys. In our lecture, we have been talking about the differences between external and public. In this lecture, we'll take a look in bigger detail at the memory. So, this lecture will be again additional information lecture. It will take some time. This will be one of the longer lectures. If you have enough information about the memory, you can skip this one. Okay, so for those ones that are staying here, let's create first example contract on which I would like to show you memory, how it works internally. Okay, so let's go this one. Let's go to contracts and let's create here a new contract. We'll call it simply test.sol. We'll copy contract headers. So from a faucet contract, let's get here license and pragma. Okay, so let's get it here. Perfect. Now let's provide here contract name. We'll not pay here much details here. We'll just call it contract test. Okay, not very creative, but I just want to get a job done here. And let's create here also function, which will be testing, and function also, let's call it test function. It really doesn't matter. Let's provide here some accessors. Let's say this will be, I will be accessing it externally. Okay, so right here external. It can be also public, but I don't have an intention right now to access here any. I don't want to call this function from inside of the contract, so it can be external. And let's write it will be pure function returns returns some value, and will return here unsigned integer, so uint. Perfect. Now I can return here some value, or actually let's do it like this. I will show you one example, more examples at once. Let's expect to get here some value. Let's say I'll get here unsigned integer of, let's say, testing number, so test number. Okay, so we are expecting to receive here test number. As I told you, when you're not specifying how many bits you have here, by default you have a 256 bits. Okay, and we'll return this value. Okay, so we can test it out. Return here test number, semicolon. Now I will use here a special operator, or a special keyword rather, assembly, like this. And in an assembly, in the curly brackets, you can write assembly code. This means you can write here lower level code as in your normal Solidity language. Okay, this is also part of the Solidity, of course, but here you can access low level instructions. So you can access specific offsets of the bytes in the memory. You can access here your storage. You have a more grained control over your resources, basically, when you are using assembly code. In the normal scenarios, when you're writing smart contracts, you shouldn't be you shouldn't be able, but you shouldn't need to use assembly. Okay, so if you are writing ordinary smart contracts, you really don't need to use assembly, but sometimes it can be useful, and definitely in this case it will be useful because I would like to show you how memory is allocated on lower level and how we can access memory in basically from an EVM execution. Okay, so in the assembly for now, what I would like to do here, I would like to just create here local variable. When you are in assembly and you are creating variables, you need to write here keyword let, and not semicolon, but this is called this column, and a normal equal sign, and you will assign here some value. Let's say number 4, and of course name for this variable. Let's call it underscore number, okay, or just a num. Okay, so inside of assembly, you are creating variables like this: let keyword, name of the variable, colon and equal sign, and the value. And you don't need to write here these semicolons in the end. You will get even error here. Okay, so we have here number, and now I will do here something interesting. I will load here some data from the memory. I will get here free memory pointer. So let's add here let. Let's call it free memory pointer, FMP, free memory pointer. Doesn't matter how you call it. And let's assign here. You can use here function mload. This means to load something from a memory, and you will need to specify a location in the memory you would like to load. I'll specify here 0x40, like this. Okay, you don't really need to understand right now these lines of code, or especially this one here. We'll be debugging it, and you will understand it throughout the lecture. Okay, so I'm loading here whatever is on the space of the memory on the position 0x40. There should be location of the free memory pointer. I will show you. Okay, now we can test it out, and we will copy this contract into Remix so we can debug this code, and you will see what values we are getting. Okay, so let's copy this smart contract. Let's open our browsers and let's search here for Remix Ethereum Remix. Okay, we'll go to Remix IDE. Okay, not this one. Ethereum Remix, where is the, here, up here. Okay. Okay, so when this will be loaded, I will create here a smart contract. So let's go to contract section. Let's click here on storage.sol and we'll just, we will override this. So I will simply remove everything from here. Of course, leave here a pragma and this, and let's copy here, paste here your contract test. Let's save it, please. We are going to compile it. So let's click here on the left side to the compile menu. Select the compiler and let's compile this storage.sol. As soon as this will be compiled, you will get the bytecode. So when you will click here compilation details, you can click here on assembly, and I want to pay you attention here for these lines of here push 80, push 40, MS store. And the same here when the contract is executed, when some function of the contract is executed, you are doing the same stuff, push 80, push 40, MS store. Okay, you can also see a bytecode here. The same thing here, 60, 80 mean push. This means push 80, 60, 40 means push 40, 52 means MS store. So basically what they are doing, I'll zoom it in for you. Basically what you're doing, you are accessing memory. So you're accessing memory at 0x40 and you are storing there 80. Okay, that's what's happening here. Okay, but what does this do? Okay, so to understand it better, we will get into smart contract. Okay, let me unzoom it. That is too much. Okay, so since we have it compiled, we can deploy it to the network. So let's click here on the left side to this menu, deploy and run transactions, and we'll deploy the contract. So let's click here, deploy. This is deployed now. I will clear the window here. So I'll click here is a circle, crossed out circle. And I will go to the contract. Here is your deployed contract on the left side, and I will open it. You have here access to your test function. See it here? Test function. And let's send here a parameter. Let's pass here a parameter. Let's say value of 3. And let's click here test. This will send a transaction. Okay, here you have a transaction. Now what we can do here, very interesting, of course we can click at this. That's the first thing. We can inspect that we have a decoded output is a value of 3. That's what we are returning because we are passing inside the 3 and we are returning the 3, this testing number. But what we have here, interesting enough, is a debug button. And we can debug execution of this function. Okay, so let's click here debug. And this will open debug window. Now in the debug window, you can move from a line to line with this button here, stop over forward, or you can write a breakpoints to jump into the specific line. For example, here mload, and here I will jump here. But before we'll jump anywhere, let's inspect here the left side. First thing here, you can see here the instruction. So you can see here bytecode of your smart contract. I'll zoom it in. Of your smart contract. Then you have here details of current step of execution. So for example, on what is the step? So the 180 execution step. Then how much gas you will spend, how much remaining gas you have. There's the address of your loaded contract. Then you have a stack here, the structure on which you are pushing the values of your operations from a bytecode. So on top of the stack, you are pushing some values. All right, and then you have here, what else you have here, interesting enough. We have here memory. That's very, very important one, because about this I would like to talk. And you can see here on the memory, at the position 0x40, you have already 80 stored. Okay? It maybe seems like it's on 0x50, but it's stored on a 0x40. I will explain shortly what is this. Okay? And then you have a call stack. Call stack should be just the address of your call stack. This should be address of your contract, if I'm not wrong. 9138, and here is a 9138. Yeah, that's a loaded address. Okay. And they call data. So that's the data you have sent in a transaction, what you should execute, and that's the identifier of your function. This is the value of a tree you are sending. I will also inspect this very shortly. All right, so first let's take a look at this here. Before even the function is executed, or when the function is executed, you can see here there is allocated in the memory on the 0x40 80. Okay, so what does it mean? You saw this instruction, push 80 into the 40 address. That's what's happening. That's what is happening here. So you have this memory. I will get my pen here and I will write it. Let's say I will write it here. Okay, so memory is the is the linear. Okay, so memory is something like this. Okay, is a chunk of a bytes, and let's imagine here have some values. Okay, memory, and memory is a chunks of a 32 bytes. So that's how it's memory allocated. If you need more memory, you will allocate 30 of 2 bytes more, 32 bytes more. Okay, so when you are storing some values into memory, you will specify offset on which you want to store it. For example, here. Okay, here on this position, you have here 0 and so other values on this position, and you will store this value on the chunk of 32 bytes. So your value will be stored on this position, and from this position 32 bytes. Okay, so value will be stored in this chunk here, in this here. Okay, of the 0F and hexadecimal characters, right? And so on. So your value will be stored here on these chunks here, and you can see these addresses here. This memory. Okay, so here is for example, I will remove this. Okay, so here you should have here 0x0. You have here, this is a 16 bytes chunk, 16. Here is another 16 chunk, 16. Here is another 16 chunk, and so on. So when I'm saying store me number 80, and storing number 80 into 0x40, I'm saying here, store it me here, right? 0x40, and take the chunk of 32 bytes. So here, 16 bytes. All right, and here, take the 16 bytes. In total, 32. So this chunk is 32 bytes, and I'm storing here 80, as you can see here. Okay, I can verify to you that this really 32 bytes. So I'll copy this on the 0x40. I will copy these bytes here. Copy all of them here. Okay, copy them. Let's go to a coding editor. Let's paste them somewhere here. Let's say here. And let's copy the other chunk of bytes. So let's start here, like this. Let's paste it. And now let's inspect this. This should be 64 characters long, which means 32 bytes, because half of it is the number of the bytes you are getting. So this is definitely 32 bytes, a chunk starting at the position 0x40. Okay, so we are storing here 0x80 here, and what does it says here is that when the smart contract needs to allocate some other values into the memory, it will be allocating them at the position 0x80. So basically, what we'll do in the virtual machine, we'll allocate more memory here. So you have here, I will be writing here. You will basically allocate more memory here. Okay. And you will have here 0x6, 0x7, 0x80. And from this position on, you will be storing the values to the memory. So here you will have these chunks of a memory, and there will be values stored. All right, and so on, 0x90, and the values will be stored in these chunks on. Okay, this will be where will be memory stored. Okay. So I think that's clear now, right? So if you have any questions, you can ask them. And let's inspect also the other things here. I will disable this. Okay, and we'll move more in our code. I need to somehow, that's too much, zoom. Okay, and what we are going to inspect now. First thing here in a stack, when the function is executed, I think this value of a 3, you can see it's a value we are sending in the transaction as the argument here, test number. Okay, I think that's what they pushed on top of the stack. You can see this number 3 here. Also, the call data here, inspect this call data. This is a signature of your function with the getStack 256 encoding, and 03 is the value you are passing in. This test number. That's your call data. Okay, so we can copy it somewhere here. So let's copy it, let's paste it here. Okay, and now let's encode your functions. So we have a test function is expecting you in 256. I will go to getStack 256. Okay, and let's get here input of, we are calling it just a test, right? And uint 256, 29e, this is the value, right? Copy first 4 bytes. Okay, and yeah, that's first 4 bytes of our function. So you can notice this will be first 4 bytes. Okay, 8 selected, this means 4 bytes. Okay, and this renaming 32 bytes is the parameter you are sending, so the 3. Okay, that's what we are sending in the function when we have been executing this function. We are passing here a function, basically identifier with a hashed version of the function name and the parameter, and this 3 is what we are passing in. Okay, then we'll go more into the code. All right, so I have here a couple of breakpoints, and I will go now to the, here you have, when you scroll up here, you have this arrow to step into the next line, and here you have a step to the next breakpoint. When I'll click this, I should step here. Here I'm just loading simply this 0x40 from the memory, the position which should get me to the pointer. This should get me value from the memory of a 80. This should get me 0x80. I'm just doing it as an example. We don't need to do much here. Let's jump over the next line. So I will click here, and I will jump here in a return, and this should return my value. Actually, let's go for a second back to the previous breakpoint. So let's click here to the previous breakpoint here, jump into previous breakpoint, and I would like to show you that this number 4 here is not stored in the memory, but it's stored actually on top of the stack. You can see here in the stack, this value is here stored on top of a stack. When you are assigning the variable, basically local variable in assembly, this is storing variable on top of the stack. And as soon as assembly is done here, when you're going to this line of code, it will be pushed out from the stack. Okay, so that's when only here you can use a value inside of this block here. Okay, guys, and that's basically what I wanted to explain you. Let's jump here back to the return line here. So let's jump here over the next breakpoint. Click here. All right, and you can see we are not doing anything with the memory, so there is no necessary to allocate more space in the memory. So we are still on 0x50. That's the entire memory we have, and we have here 0x80 stored in this memory spot here, the chunk over 32 bytes. Okay, I think now everything is explained here. There is also storage, but storage should be empty in this case, and we will be talking storage in a separate lecture. I will leave this AI lecture here. We will continue next one, and it will be also long lecture. I would like to continue with this memory. I would like to show you more examples how the actual data are stored in the memory, because so far we are not storing anything here. Alright guys, so that's gonna be it, and I hope to see you in the next one. Cheers.